Electrochemical reaction is any process either caused by accompanied by the passage of an electric current and involving in the most cases the transfer of electrons between two substances, one a solid and the other a liquid. Reduction oxidation refers to electrochemical processes involving electron transfer to or from a molecule or ion, changing its oxidation state. This reaction can occur through the application of an external voltage or through the release of chemical energy. First thing we did was calculating the total molar mass for each material in order to get the mass will be used for 50 ml of water. At this time, the laboratory specialist is showing us various elements that we will be using in our lab session. After calculating how much material we need, the material is being measured using a high precision scale. Sure was taking that the scale is set to 0 before pouring the material, and the procedure was repeated for the other materials. Now, the laboratory specialist is explaining how to use the volumetric pipette, which is a high accuracy tool to measure the water needed to make the solution. The small bit of water remaining in the tip is not considered part of the 50 ml, such that the amount of water used is very accurate, and a solution for all materials has been done. After pouring the water into the material, a magnetic sphere was put inside such that it moves when the solution is taken to the mixing chamber, which mixes it very well. The procedure is then repeated for the other solutions. The first scale we used started to give wrong readings, so we used another weigh scale. Now we are putting all solutions in a bath of a temperature of 25 degrees Celsius, such that all solutions have the same temperature. The paper, which works as bridges, were folded and put into a salt solution. One paper for each solution was done to prevent any contamination. Now the electrodes is being cleaned using a sandpaper in order to remove the oxide. We tried as much we could to have equal size in the cathode and anode. Now we are using the folded papers to make bridges between the cathode and anode to measure the voltage across the cell. The negative readings refer to the direction of electrons. After measuring the voltages, the best voltage with regards to the theoretical came to be the CuAg cell, so we choose it to be our cell in the second part. All solutions now are being cooled to a temperature of 10 degrees Celsius with the aid of using ice bottles. We took measurements of voltage in increments of 5 degrees, starting from 10 degrees to 50 degrees Celsius. As you can see in the picture, the anode, which is the copper, got oxidation after the experiment due to flow of electrons.